Series and parallel networks. We need to know some of the series and parallel networks and how to calculate when they are in series and parallel networks for resistor, capacitor and inductor. For resistor, if the resistors are in serially connected like this R1, R2, R3, if they are connected to node, then we can calculate the R equivalent, the total resistance as R1 plus R2 plus R3 and so on. If there are n number of resistors also, we need to add them. And if the resistors are in parallel, that is from node to node, for the same node different resistors are connected, that is in parallel like this, in this fashion, then the R equivalent will be calculated as 1 by R equivalent, 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by Rn. If there are n number of resistors also, we need to calculate in this way if the resistors are in parallel. Okay, then and lastly, while writing the R equivalent, if you get like some x by y form, if you get 1 by R equivalent as x by y form, then R equivalent will be y by x. Why? Because it is a reciprocal. No, why? Because 1 by R equivalent is x by y. R equivalent will be y by x. We need to change the denominator to numerator and numerator to denominator after calculating. If the capacitors are in series, capacitors is just opposite of the resistance. Capacitors, if they are in series, we write 1 by C equivalent is equals to 1 by C1 plus 1 by C2 plus 1 by Cn. That is, n number of capacitors are calculated if they are connected in this fashion in series. Then we'll write, this is same as resistance. Just the opposite. For resistance, if they are in series, we calculate in this way. If capacitor, if they are in series, we write in this way. And if capacitors are in parallel, we are going to add for getting C equivalent, C1 plus C2 plus C3. If you see, this is same as this. It is ulta. For series, we add them, but here for parallel, we add. For parallel, we are going to do 1 by R equivalent, 1 by R1 plus 1 by R2 plus 1 by R3. But in series, for capacitor, we do like this. So it is an opposite way we consider. But inductor, it is same like resistor. If inductors are connected in series, we are going to add them, L1 plus L2 plus L3. It can be n number of inductors. If inductors are in parallel, then same like resistance, what we do, 1 by L equivalent is equal to 1 by L1 plus 1 by L2 plus so on 1 by Ln. If